Good evening, everyone. So let's start the 11th lecture for three-dimensional geometry. Three-dimensional geometry, lecture 11. Okay, so in this lecture, we will be covering the topic of sphere. Sphere, okay. So basically, first we should understand what do you mean by the concept of sphere. So sphere, like we have circle in two-dimensional geometry, we have a sphere in three-dimensional geometry. Okay, like circle is in two-dimensional geometry, sphere is in three-dimensional geometry. Okay, so let's continue with this. So we can say it is defined as the locus of a point which moves in space, locus of a point which moves in space in such a way that in such a way in such a way that its distance which moves in space in such a way that its distance from a fixed point which moves in space in such a way that its distance from a fixed point always remains constant, which moves in space in such a way that its distance from a fixed point always remains constant. Okay, so we assume that suppose this is a sphere and we have a center whose coordinates are h comma k comma u, and we have a point p x comma y comma z which is lying on the circumference or the boundary of the sphere, and suppose the radius is r, so we can say that pc is equal to r. If we take square on both the sides, so pc square will be r square. Now apply distance formula. So x minus h whole square plus y minus k whole square plus z minus u whole square will be equal to r square. So it's very similar to the concept of circle which we have studied in two-dimensional geometry. The difference is only that now since we are dealing with three-dimensional geometry, so we will also have to adjust the z coordinate. Okay, so x minus h whole square plus y minus k whole square plus z minus u square is equal to r square. So let's start with the vector form here. So vector form, what will I do is I'll draw a sphere like this. Let's suppose there is a point C. The position vector of C is C vector and position vector of P is R vector. So we take the R vector. Point A, which is origin, is lying outside the sphere. Now we take this as null vector. So I can, using the vector law of addition, I can write as OP vector is equal to OC vector plus CP vector using the triangle law of vector addition. Triangle law of vector addition. OP vector is equal to OC vector plus CP vector. So OP vector is R vector, OC vector is C vector plus CP vector, which means we get CP vector is equal to R vector minus C vector. CP vector is R vector minus C vector. Okay, so now we come to this relation mod of CP vector is equal to A. So if we take now CP vector is R vector minus C vector. So in place of CP vector, I can write R vector mod of R minus C is equal to A. Now take square on both the sides. So square of magnitude of R vector minus C vector is equal to A square. Now square of magnitude of R minus C can also be written as dot product of R minus C with itself. So I can write this as R minus C dot R minus C. Okay, so R minus C dot R minus C is equal to A square. So this is sphere's equation of the sphere in vector form. Now continuing further, we come to the Cartesian form of sphere. Continuing further, we come to the Cartesian form of sphere. So now we need to find the Cartesian form of sphere. So in order to find the Cartesian form of sphere, we can write the let's suppose that the vector C, which is the position vector of the center of the sphere, C1 I cap plus C2 j cap plus C3 k cap, and vector R is X I cap plus Y j cap plus Z k cap. Okay, so now we know that mod of R minus C is equal to A, as I just told you in the previous explanation. So R minus C can be written as X minus C1 into I cap plus Y minus C2 into J cap plus Z minus C3 into K cap is equal to A. So in order to find the modulus or magnitude of this vector, I will apply this formula: square root of X minus C1 square plus Y minus C2 square plus Z minus C3 square is equal to A. Now if we square on both the sides, squaring on both sides, so let's continue. So if we square on both the sides, square root will be removed. So we will get X minus C1 square plus Y minus C2 square plus Z minus C3 square is equal to A square. So this is the equation of the sphere. Okay, so now if we expand all the terms, so we get x square plus y square plus z square minus 2c1x minus 2c2y minus 2c3 into z, and then c1 square plus c2 square plus c3 square minus a square is equal to 0. On expanding all the terms of the equation, x square plus y square plus z square minus 2c1x minus 2c2y minus 2c3z and plus c1 square plus c2 square plus c3 square minus a square equal to 0. Okay, so let me just clear some part. So now if we write the equation of the sphere in this form, x square plus y square plus z square plus 2ux plus 2vy plus 2wz and then plus d equal to 0, and compare this equation. So this is the, we can say, the general form or the Cartesian form of sphere. So now if we compare this form of equation of sphere with this form, so we get u is equal to minus c1, then v is equal to minus c2, and then w is equal to minus c3, and d is equal to c1 square plus c2 square plus c3 square minus a square. Okay, so the coordinates of center are c1, c2, c3, which means if you want to write in terms of u, v, and w, the coordinates of center will be minus u, minus v, and w, and radius is nothing but a. So radius, formula for radius you can write as square root of u square plus v square plus w square minus d. Okay, so coordinates of center of the sphere will be minus u, minus v, minus w, and radius for the sphere, you can write down radius for the sphere by this formula: square root of u square plus v square plus w square minus d. Okay, where d is the constant which is given in the equation of the sphere. Okay, so let's continue ahead. Let's take some questions now. Question 1. Find the equation of a sphere whose center is 3, 1, 2 and radius is 5. So a is equal to 5 in this case. Find the equation of the sphere. We have to find the equation of the sphere. Find the equation of a sphere whose center is 3, 1, 2 and radius is 5. Okay. So in this case, we assume the point P is x, y, z, which is lying on the circumference of the sphere. So we can write the distance of P from center. P is lying on the boundary and C is the center will be equal to the radius. And radius is nothing but 5. So PC length is equal to 5, which means PC square will be equal to 25. PC square is equal to 25, and now you apply distance formula. So x minus 3 whole square plus y minus 1 whole square plus z minus 2 whole square is equal to 5 square, which is 25. Now expand all the terms. So we get, after expanding all the terms, we get x square plus y square plus z square minus 6x minus 2y minus 4z. 9 and 1, 10, 10 and 4, 14. 14 minus 25 is minus 11 equal to 0. So x square plus y square plus z square minus 6x minus 2y minus 4z, and then minus 11 is equal to 0. So we got the equation for the sphere like this: x square plus y square plus z square minus 6x minus 2y minus 4z, and then minus 11 equals 0, because 9 plus 1 was 10, 10 plus 4 14, and then 14 minus 25, so minus 11 equal to 0. Let's take another example now. Let's come to question number 2, another example. So here it is saying find the equation of the sphere. Find the equation of the sphere which has center at the origin, which has center at the origin and touches the line 2 into x plus 1 is equal to 2 minus y is equal to z plus 3. 2 into x plus 1 is equal to 2 minus y is equal to z plus 3. So this is the equation. We have to find the equation of sphere which has center at the origin. Center at the origin. Okay, center at the origin. So center point is 0, 0, 0, and the sphere is touching a plane. Okay, sorry, sphere is touching a line. Sorry, sphere is touching a line, and the equation of that line is given to us. 2 into x plus 1 is equal to 2 minus y is equal to z plus 3. So we want to find the equation of a sphere. The center of the sphere is given as 0, 0, 0, and the line which is the sphere is touching, that equation of line is also given to us. Okay. So in this case, we can write the equation of line like this: x plus 1 upon half is equal to minus, or we can say y minus 2 upon minus 1 is equal to z plus 3 upon 1. Okay. So suppose the point at which the sphere is touching the line, that point is P. So we can write the coordinates of that point in terms of lambda. Okay, if I equate this equation of line in equal to lambda, so I can write the coordinates of that point in terms of lambda. So x coordinate will be lambda, like coordinates of x will be lambda by 2 minus 1, then minus lambda plus 2, and then 1 into lambda, so lambda minus 3. So these are the coordinates for point P. And we already know the coordinates of center C. So by subtracting their respective coordinates, we can calculate the direction ratios for CP. So lambda by 2 minus 1 minus 0. So lambda by 2 minus 1, then minus lambda plus 2 minus 0, and then lambda minus 3 minus 0. So we get the direction ratios of CP as this: lambda by 2 minus 1, then 2 minus lambda, and then lambda minus 3. Okay. So let me just erase some part because There's some lack of space. Okay. So now we got the direction ratios of CP. Now we know that CP is perpendicular to the line L. So if we know the direction ratios of line, we know the direction ratios of CP. We can apply this formula: A1 A2 plus B1 B2 plus C1 C2 is equal to 0. We can apply this formula. Direction ratios of line we already know, that comes in the denominator. So this is half, then minus 1, and then 1. Direction ratios of the line are half, minus 1, and 1. Now we apply. So lambda by 2 minus 1, multiply this by half. Then we get 2 minus lambda and multiply this with minus 1. 2 minus lambda into minus 1. And the third direction ratio is lambda minus 3. Lambda minus 3, multiply this by 1. So this is equal to 0. So here I applied the formula A1 A2 plus B1 B2 plus C1 C2 equal to 0. Now if we simplify this, we get lambda by 4 minus half minus 2 plus lambda and plus lambda minus 3 equal to 0. Right? Lambda by 4 minus half, then minus 1 multiplied with this. So we get minus 2 plus lambda and then lambda minus 3. So lambda plus lambda is 2 lambda, 2 lambda plus lambda by 4. So we get 9 lambda by 4. 2 lambda plus lambda by 4 is 9 lambda by 4. Then minus 2 minus 3 is minus half, minus 5. And minus 5 minus half is minus 11 by 2 equal to 0. So from this equation, we get the value of lambda as 11 by 2 multiplied by 4 by 9. From this equation, we get the value of lambda as 11 by 2 into 4 by 9. So 11 into 2, so this is 22 by 9. We get the value of lambda as 22 by 9. So again, I need to create some space in order to solve further. So I got the value of lambda as 22 by 9. Now to find the coordinates of coordinates of point P, I need to put the value of lambda in the coordinates. Okay. So point P will be lambda by 2. So lambda is 22 by 9. So by 2 means 11 by 9 minus 1. And then 2 minus lambda. So 2 minus 22 by 9. And the z coordinate is lambda minus 3. So 22 by 9 minus 3. So this will become 11 minus 9. So 2 by 9. Then 18 minus 22 is minus 4 by 9. And then 22 minus 27 is minus 5 by 9. So in this way, we get the coordinates of point P as 2 by 9, minus 4 by 9, and minus 5 by 9. Now we know that this length, the distance between C and P, is nothing but the radius of this sphere. Okay. So I will just create some space here by removing this part. I got the coordinates of P, and now I can apply distance formula to find the radius. So radius is equal to square root of 2 by 9 minus 0 ka square, so 4 by 81. Then minus 4 by 9 minus 0 ka square, so 16 by 81. And then minus 5 by 9 minus 0 ka square, so 25 by 81. So this is 4 and 16, 20, 20 and 25 is 45. So 45 by 81. Now 9 5s are 45, 9 9s are 81. So root of 5 by 9, which means we can write the radius as root 5 by 3. We get the radius of the sphere as root 5 by 3. Okay, so I found the value of radius as root 5 by 3, and we know the coordinates of center is 0 comma 0 comma 0, which means center is nothing but origin of the coordinate system. Okay, so now we can apply the distance formula. Now we can apply the distance formula and get the equation of the sphere. Now we can apply the distance formula and get the equation of the sphere. Okay, so let's suppose we have this point R which is lying on the sphere. The coordinates of R is x comma y comma z. So now since R is lying on the sphere, its distance from the center of the sphere, which means RC, will be equal to the radius which we have calculated, and we have calculated the radius as root 5 by 3. So now if you take square on both the sides, RC square will become 5 by 9, and then you write RC square using the distance formula. So x minus 0 ka square x square, then y minus 0 ka square y square, and then z minus 0 ka square z square is equal to 5 by 9. And then if we cross multiply and rearrange the terms, we get the equation of the sphere as 9x square plus 9y square plus 9z square minus 5 is equal to 0. We get the equation of the sphere as 9x square plus 9y square plus 9z square minus 5 is equal to 0. Okay. So I hope you understood. I introduced the concept of sphere and then I took two examples based on that. So I think we can do questions based on this concept in the next class, and then tomorrow I'll like post another video which is related to spheres. Okay. So I think this much should be enough for today's lecture. Okay. Thanks for listening. See you tomorrow.